All right, so good evening, everyone. It feels good to be back after a long time. So, we'll be discussing the problem unique paths from Leetcode today. Okay, the problem number is 62, and yeah, it's a problem of the medium category. So, we'll be firstly discussing the approach for this question on the whiteboard, and then I'll code the solution for you guys. Okay, we are back after a long time, so I'm currently taking a medium category problem. So, yeah, let's probably just move on to the whiteboard now. Just give me a minute. Okay. All right. So let's just have a heading here firstly. So we are discussing Leetcode 62 unique paths. All right. I'm recording this video on 8th September, timing being, let's say, 4 p.m. just for a track. Okay. So yeah, let's just firstly read the problem statement, in fact. Okay. So there's a robot on an M into N grid. The robot is initially located at the top left corner. The robot tries to move to the bottom right corner. The robot can move either down or right at any point of time. Okay. So we have been given an M into N matrix. That's a grid. We do not have any obstacles in this case. So the robot is free to move to any cell. But the only possible movements for the robot is the right side and the down side. Okay. So what do we need to tell? Given the two integers m and n, that is the size of the grid, return the number of possible unique paths that the robot can take to reach the bottom right corner. Okay. So we need to find the total number of paths by which the robot can reach the bottom of this grid. That is the bottom rightmost corner. Yeah. This cell. Okay. This one. Okay. We need to find the unique paths. Okay. So we'll keep that in mind. So we have the problem constraints here. Okay. That's not a very high constraint. So we can go for an n square solution for this. Now, probably let's just move on to this thing, discussion for this. Okay. So just for this, I'll firstly recommend all of you, if it's good if you guys know about DFS and DP. Okay. These two approaches can be used to solve the question. Okay. The DP solution would be a much easier one and less time consuming. So I'll discuss the DP solution here. Okay. Although the approach is same in both the cases. So yeah, these are the two possible methods. This is the recursive method and this is the non-recursive bottom-up DP. Okay. Bottom to top. Okay. Bottom to top DP. All right. So let's firstly see. Okay. Let's suppose we have this grid. Okay. I'm taking a very small grid as of now. Please ignore if that's a bad drawing. So yeah, that's a 3 into 3 grid. I'm taking a symmetric one as of now. Okay. This is our finish point. Okay. So, and we have been told that the robot can either move down or he can go to his right. The robot cannot go in this direction or this direction. So let me change the color for you. Wait a minute. Yeah. So the robot is not allowed these two movements in any case. This is the only possible movement which the robot can take. This one or this one. Well, what can we, when we firstly see the question? When you have a problem, you firstly try out to figure the edge cases. If we are going for a bottom DP, that's very important to firstly figure out what our edge cases. Okay. So I'll make the grid again for you guys here. That's our grid. So if I'm currently at the start point, this is my for any of these cells, this row, first row, or the first column. Answer for all these cells would be 1, right? If you see that if you are at point, you can go for this point by only one. That then there is only one possible path. That is this only, right? You cannot go down and then come here. That is not possible because you cannot go up. Okay, this is not possible. Okay. Go. Take my pen again. I'll redraw it. So for similarly for this cell and similarly for these two cells. Okay. I hope that should be clear to you guys. दोनों केसेस में अगर ध्यान से देखोगे तो और कोई पाथ नहीं मिलेगा फॉर दी सेल्स विच आर इन द फर्स्ट कॉलम. ठीक है, फॉर दोज केसेस यू कैन ओनली गो डाउन. ओके, you cannot go right because if you go right then you'll have to come back in this direction, which is not possible, which is not allowed in fact. Okay, similarly for these cells you can only go right here. Okay, you cannot go down in this case. If you go down then you'll have to come back up, which is again not allowed. So these two operations won't fetch us any good answers. Okay, wait, just rub this again. Okay, these are the two possible cases. So this is our base case. Now let's ये तो बात हो गई base cases की. Now if we come on to any cell which is in the middle of the grid, which is not in the first row and the first column, so उसके लिए हमारे पास क्या possible answers हो सकते हैं. Let's suppose I am at this cell. ठीक है, so if I see, एक छोटा सा एग्जाम्पल लेके देखते हैं. अगर मुझे यहाँ पे आना है, इस सेल में आना है, तो मेरे लिए आंसर्स क्या पॉसिबल होंगे. यहाँ तक पहुँचने के कितने आंसर प्लस यहाँ तक पहुँचने के कितने आंसर्स, राइट. इफ आई टेक द सम ऑफ दीज टू सेल्स, लेट्स सपोज आई वांट टू कम हियर, दैट इज आर कॉमा सी. ठीक है, सो माय आंसर वुड बी आर कॉमा सी माइनस 1 एंड आर माइनस 1 कॉमा सी. Those are the only two possible cases, right? If I can come at these two locations, let me change the color. Wait. Yeah. Let's take red color. Okay. If I want to come here, so these two possible cases can give me the correct answer only. If I have an answer for these 2 points, that is r comma c minus 1 and r minus 1 comma c, only then can I find out the answers for this case. Okay. All right. Try to visualize it. ठीक है. If you can come here, then the number of paths for this location would be the number of paths for this location and the number of paths for this locations, right? So yeah, I think that gives us a final answer for each cell. So that is how we'll build up our bottom-up DP. Okay. Bottom-up कैसे हुआ? We'll go from I is equals to 0 till I is less than n, I plus plus. Inside that we'll have a nested loop. Okay, j is equals to 0, j is less than m, j plus plus. Okay, we have our nested for loops. Okay, this is one for loop, this is another one. So if I want to come here, let's suppose this cell, which is, let's suppose this is I comma j, not r comma c. Let's take it I comma j, okay, as the notations. Okay, and let me just work this out. Let's just move to our next page. Okay, let's just move to a separate one. Okay. What further we had? Okay, so this is where we were. Okay, this was our grid. Okay. Tangent. So this is our start point and this is our finish point. Let's suppose that if I am at this point, okay, if I want to come here at till this point, okay, let's suppose my finish point is this one, this circled one, okay. So what will be my answer? My answer will be the sum of this cell plus the sum of this cell, number of ways, okay. And what is the answer for this? The answer for this was already 1. We had pre-calculated. And for this is 1, okay. So what will be the answer for this cell? The answer for this would be 1 plus 1, which is equals to 2. Now we can cross-check whether the answer is correct or not. So if I need to, let's suppose I move my finish point here. Let's just assume this for a moment. So what will be my possible ways? From start, I go right, I come down, and I reach here. Okay, that is one answer. Another case would be, I start from here, I go down first, okay, then I go to right, okay, and I reach my finish spot, okay. So these are the only 2 possible cases. You can check whether if you find any other cases, but that is not possible, okay. Considering the movements we have been given, if we had been given this back movement or upside movement, then it would have been a different case. But considering these given 2 movements only, we can find only these 2 solutions. So let's probably move on to the bottom of DP, okay. So how will we build our bottom of DP and reiterate through this, okay. As we discussed earlier, for every cell the answer is I minus 1 comma j plus I comma j minus 1, where I is my row and j is my column. Alright. Okay, so I'll run a nested for loop. I is equals to 0, I is less than n, I plus plus. By the way, I'm taking an n into m grid at the moment. Okay? We'll change the variable names accordingly when we code. J is equals to 0, j is less than m, j plus plus. Alright. So the answer for our dp ij would be, as I said, I minus 1 comma jth 1 plus I comma j minus 1. Okay. Let's write the formula here. So the final result comes out for the ith, for the cell in the ith row and the jth column. The answer comes out to be this dp of I minus 1 comma j plus dp of I comma j minus 1. Alright. And these 2 answers would be pre-calculated. Okay, when we move on to our code, you'll see how we can pre-calculate these answers. Okay, just give me a minute. Okay. Yeah. These 2 answers, this will be pre-calculated from our for loops. Okay, for loops कैसे चलते हैं हमारे? अगर ध्यान से देखो तो 0 से n और j के लिए 0 से m में जाएंगे. ठीक है, तो और हमें आंसर कैलकुलेट करना है आई जे का. सो i माइनस 1 के लिए तो ऑलरेडी आंसर कैलकुलेट हो चुका होगा, राइट, फॉर लूप्स में पहले. सिमिलरली फॉर j माइनस 1 आंसर ऑलरेडी प्री कैलकुलेट हो चुका हो. ठीक है, नाउ वी चेक द टाइम कॉम्प्लेक्सिटी एज वेल. द कॉम्प्लेक्सिटी फॉर दिस अप्रोच वुड बी O of n into n. Okay, this will be a final complexity. How will we reach this complexity? I'll tell it to you in the code once we move on to the code. So I think the approach should be pretty clear. That's an easy problem. So probably we can move on to the coding part now. Okay, so I'll just keep this aside, keep my whiteboard aside. Let me just come back to my desktop. All right. Just let me charge that as well. Just okay. Yeah. So we are having here an m into n grid. Okay. That is our size. That means m is the row and n is our columns. Take rows and columns. Okay. As I said, firstly we'll build up a 2D array, okay, for storing our final answer. All right. So because we need to calculate the answer for all the possible cases, okay, for all the cells. So we'll have to store them somewhere. So we can create a 2D array, okay, of size. In fact, that should be m into n, not n into m. Okay. Yeah. So let's move on to the base cases as I discussed. What were our base cases? Let's switch back here. What were the base cases? Well, the base cases were that the answer for the first row and the first column is going to be 1 only, because there's only one possible method, okay? So we'll store the base cases first in the 0th row, okay? I'll take my row as 0. Okay. Wait a minute. That is the m. Okay. So we are taking row number as 0. So firstly, we'll have to iterate over the columns. Okay. So let's make a convention that we'll be using j for columns and I for rows. Okay. This will help you avoid confusions in future. Okay. So we'll store this answer as 1. We are now done for all our columns of first row. Okay. Now we'll move to all the rows for the 0th column. Okay. This is in fact n, not n. Okay. And I is less than m, comma I plus plus. So we'll do dp of I of 0, that will again be 1. Okay. Alright, so we are done with our base cases, I think. Let's just cross check. This is for the rows, as I said. First column. Because you see column number is 0 here. Okay. So, yeah, I think that is good enough. Okay. Now let's move forward. Let's move on to our main solution. Okay. I is less than m, I plus plus from integer. J is equals to 1. J is less than, not m, that should be n again. I'm just pointing out because students make a mistake. It becomes a convention that you take n as the rows and m as the column. So if you still want to follow that convention, you can do a swap operation here between n and m. Okay. So this will swap the values of n and m. Okay. So then you can use n as your row number and j as your column number. Simple. Now, what did we discuss for the solution? What was the final formula from the bottom up dp? Okay, this was a final result, I minus 1 j, I comma j minus 1, right? So we'll do that only. Okay, so I'll store the answer for I comma j as dp of I minus 1 comma j plus dp of I comma j minus 1. Okay, and what do I need to return? I need to return the answer stored at the cell m minus 1 comma n minus 1. Observe this carefully. We wanted the answer for this cell only. Okay. So how do we represent this cell when it comes to a 2D matrix? Okay. That will be the last row. So the rows are 0 indexed, right? So the final row number would be m minus 1. And the same goes for the columns. Columns are also 0 indexed. So we'll take the column n minus 1. So this stores our final answer. Okay. Now let's just check it once again. Let's just go through our code once again, just before submitting. Okay. We prepared a 2D matrix. Okay. What we did here was that we just created our base cases. So what was our base case? That you set all the columns of the first row to 1. Okay. That was our case. So did we do that? Yeah, let's check what is our column number n. Maximum value can be n minus 1. So j can be less than n. Okay. So dp of 0 j. 0 is our first row again. 0 comma j we have set it to 1. Similarly for this case, 0 I we have taken a rows to be I is equals to 0. I is less than n. I plus plus. dp of I 0 and that is again set to 1. Okay. Yeah. Okay. This column number is correct. Again, the row number is also correct. So yeah, I think we are good to go. Let's just try to submit this once. Okay. Let's firstly check if we have any other base cases or not. Firstly, let's run. Yeah, I don't think we need to handle any other base cases. So this seems fine to me. So probably let's just run this code. Okay. So it's working fine on the sample test cases. Now let's submit this post. Okay. So runtime 2 milliseconds. Okay. So we have submitted a code. Although I had solved it previously, it's an easy problem. So now let's go through the time complexity. Okay. This is just a declaration, so this won't really have any complexity. So we mark this as O of 1. Okay. Let's come on this case. Complexity for this part would be, if you check it, it would be O of n. Okay. Because we are iterating n times. Complexity for this part is O of n. Now, complexity for this loop would be O of n. So, complexity of this part would be O of n, right? Now, if you check these two, this is a nested loop, okay? So, individually, even though they have a complexity of O of m and O of n, but they are running like a nested loop. So, the complexity in this case would be m times n for this complete loop, okay? Because let's suppose currently you are on one value. J runs n times, okay? Precisely n minus 1, okay? But that won't matter because we are taking the worst case time complexity. So it is running n times then. So this loop runs m times and this n. So n into n. For every iteration, the inside loop runs n times, okay? So for one iteration, if it runs n times, so how many times would it run for n iteration? No, not n, m iterations. That would be m into n, right? M into n. So the worst case complexity becomes m into n in this case. And finally, we return our answer. So the complexity for this was O of 1. Again, so we'll take the worst case complexity, which comes out to be this part, okay? If we sum it up and we take the worst case complexity, then it would be m into n, okay? You can refer to any other tutorials if you want to study about time complexity, okay? So now, well, one doubt I would like to highlight, that is, which I've seen most of the students feel. So what is the difference between the DFS approach and this one approach? Okay, the recursive approach and this approach. Okay. Difference goes with the space complexity you'll be using. The time complexity in both the cases would be same. But in case of a recursive solution, if you remember when you guys might have studied recursion, you were told that recursion requires additional auxiliary space. Wait a minute. Auxiliary space complexity for storing. Okay. For storing the recursive calls in the stack. You guys might have known about this. Okay, whenever you call recursion, the calls are stored inside an auxiliary stack. So if we want to save that space, we go for this solution because in this case, we are not using any stacks. Okay. All right. This space you will be using in that case as well. So that makes it the same. But the additional space which was used in recursive approach is the auxiliary space complexity for storing the calls, for storing the recursive calls, right? So you can avoid that by following this approach. Okay. And now just coming on to that part, if you guys might have a query regarding this, okay, why are we taking this I minus 1 and j minus 1? It might be a possibility that the answers are not stored. Okay. So let's check it. Let's just take an example that the value of I is 2 and j is 2. So answer for this would be I minus 1, that is 1 comma 2 plus 2 comma 1. Okay. So just check it with the for loop. What would have happened in the for loop? It would have gone from 1 till 2. Okay. Before it came to 2. And this one also, it would have gone from 1 to 2. So can't I say that it would have already reached this points previously? Okay. before 2 and 2, these points would have come. Because if row number was 1, okay, so row number 1 would have definitely come before row number 2, right? So that is for sure that all the answers for row number 1 would have been calculated previously, for sure. And same goes for j is equals to 2, all right? Even if the row number was 2, then we want the answer for 2 comma 1 to calculate the answer of 2 comma 2. Listen very carefully. We want the answer of 2 comma 1 for calculating the answer for 2 comma 2. So 2 comma 1 would have been calculated before 2 comma 2. Isn't it very obvious? Okay, this loop would have firstly taken 1, then it would have come to 2. So this would have firstly calculated 1 for the column, and then it would have come to 2. Okay. So, of course, it would have calculated these answers previously. So again, that case won't arise wherein you will have some garbage values stored, because you are going from bottom to top. Okay. So you're already calculating answers for all the cells before reaching the final. So, okay. So yes, I think this finishes this tutorial for unique paths problem. Okay. I hope you guys liked it. I've been back after a long time. I was busy with my placement session. So please do like, subscribe and share. And share this video with your friends. This will give me motivation to create more such videos. This was a first video after a very long time. That is why I've recorded a very simple problem. Okay. But we'll be back with the difficult problems for different platforms. I'll even share my tips for the placement session if you guys want. But again, you guys will have to support me with this, okay? So I expect that you guys like it, and if you have any suggestions, you can leave your suggestions in the comment section. So yeah, let's meet in the next video. Cheers, have a great time, happy learning.